Hello ladies and gentlemen, what's up? It's Papa Bale and welcome to the channel. And currently we're looking at, well, it's an axial flux motor, but on top of it is we got a stationary aluminum disc. Then we got two coils, what I consider to be just out of range of the magnetic fields, but just in range of the eddy current fields. And we get very small voltage, almost a volt, off of these two coils in series. So I would definitely assume that that is not from the magnets. But we're going to find out. So stay tuned. I'm going to remove the aluminum disc and put that little 1/16 of an inch of plastic down where the aluminum disc is and put the magnet wire on top of that and see what we get. So it's roughly 7.5 or 3/4 of a volt. Alright, so I'll be right back. Alright, I feel like we're going to be generating way more because we lost a 1/4 of an inch on the aluminum disc and the air gap for that. So let me make sure this thing will spin, then we'll hook up the power. Oh yeah, we're already getting way more. So I don't know, how do we compensate for, well, and the aluminum is yoking the permanent magnets, so I'm pretty sure that that was all eddy current. So, well, let's run it like this just for, S&G. Damn. So wow, this is like really, that might have been from the magnets, I don't know. We get about 3 volts from the magnets at an 1/8 of an inch closer. But that's what we're trying to do. Instead of spinning the disc and making a whole new AC build, we're going to try and spin the magnets and leave the disc steady. And I don't know if these magnets are the right ones. I got an idea though. It might actually work for this. I got a rotor of ferrite magnets, 6 position, but they go really close to the shaft. There it is. Alright, it looks like one of my clips, I'm using the magnetically inclined clips. So that's like not good. Alright, so this will go in the middle on there. And I think because of the big magnets, it will spin on 3 instead of 6, which will be dope. So we'll lift this up. And we'll get our wrench. Haha, I heard a joke about that. I really don't like these nuts. They're like hex nuts the size of, just very small. Okay. So we'll put this. All right, so that's on there like that, and that'll give us more, you know, right under the disc here, like waka, you know, bow down. Should be pretty dope. I want us to try it. All right, I'll be right back. All right, so we removed the blue thing and we're generating like a little bit more than half a volt through the yoke. So I would say that's where we're at, especially with these coils. I think it's pretty good. It's 32 and 26 gauge. Probably work better if we were spinning the disc, but you know, right here we're keeping the disc pretty steady. I mean, it is set to spin, so it'll spin a little tiny bit. But as you can see, the blue tape there, the aluminum disc is steady. And we're generating the eddy current through the magnets moving, which was the easiest way for me to do it right now. See, that's straight through there, and those are just resting on top. So this is definitely a good setup to, you know, maybe not to generate because it's looking pretty weak, but definitely to for it to work. You know, it is showing about 0.7 of a volt. These coils are 32 gauge and 26 gauge bifilar coils that I just wrapped in series, and we're still only getting like a 0.7, but I think it's good because I don't know, it's going through a bridge rectifier because it is AC voltage. I was going to charge a capacitor with that, but then I was thinking maybe it's just from the magnets. You know, it's energy getting through the aluminum, but that's a 1/4 inch of aluminum, so I don't know. But I know the more that I drag these coils to the edge, like over the edge, the more voltage you get. So we get like 1.5, you know, more, you get more, but that's definitely the magnets are playing a part in all that. More of a part, because there's nothing yoking the magnetic, you know, force, and that's kind of what you're getting here. All right, well, I think that is pretty awesome. I don't know if you can really call it educational, but I think it's solid data. So like 50 completely yoked. So eddy currents of like 0.5. Dang. Don't know what I'm doing wrong. Maybe I'm using the wrong kind of wire. Maybe I'm using the wrong format bobbin. You know, starting with the wrong shape. That could be the thing. But anyway, I think it's a win for me. I mean, if those are not, if that's electricity and it's not being generated by the magnets directly, that's a win. And here's my circuit. The light is on. Through a resistor, I'm not quite sure how big it is, I found it lying on the table. And this one goes through 20 and 22 gauge, I believe. Through a huge coil. Like it's a lot of turns of a lot of different wires. Well, it's a trifilar coil. You got a 32 gauge, you got a 22 gauge, and you got a 20 gauge. I'm pretty sure that's what it is. For the drive, oh no, the 32 gauge is the trigger coil. And I've been having a dandy with that. I had to flip flop everything just to get it to run yesterday, and then I finally figured it out. And it was that the drive was not coherent with what was going on. It was like the way I had the drive, it was facing the table. All the power was going to the table. So when I flipped it around, all the power was going where it needed to go, and everything worked out. I know that's dumb, isn't it? All right. Well, I think this is a win. I do. I mean, it's a very little win. I might definitely do something else with those coils, but I guess it's a contactless dynamo because none of that stuff is touching each other. Okay, so that's all good. And that disc is steady. I was trying to get it to, the magnet to interact with the disc more by putting this one in there. And I might be able to do that again, but the readings sucked. They just sucked. I mean, I turned it on in 0.07. 0.007. Like 007. Yeah, you got the joke. That's funny. So this is like pickup coil for eddy current. And I can see how this is not generating a lot of current. For one, it's permanent magnets. But I could see how you could generate some. This is on the very edge of the magnet, like the magnet goes to about right here, depth of that disc. So to get it right in the middle of the magnet, you need to put it out here like this. And moving this thing around is not a sin. I mean, it helps out a great deal figuring out where the actual swirl is happening. I like to go right by the coil, and it's usually not there, actually. It's kind of like right after the coil, or 22 degrees after the coil. That's 22. That's terrible. There you go. That's just after the coil and kind of hanging off the edge. So the coil I'm talking about is down here. It's kind of lined up just after the coil, making for some pretty good numbers there. Granted, that's just 1 volt, 1.5 volts. But I'm thinking that energy could charge a cap pretty quick, if it is what I think it is. Alright, well, thank you very much. Peace out. Have a good day. Please subscribe, hit the like button, notification bell. Peace out.